Wall framing is like the skeleton of your house. It provides the structure and support for your walls. Framing is essential for a strong and stable building. Without strong walls, your house wouldn't be safe. Learning the basics of wall framing is a great step towards building your own structures. This guide will walk you through the essential components of wall framing. We'll cover everything from the basic building blocks to common techniques and potential pitfalls. Whether you're a complete beginner or just looking for a refresher, this guide will equip you with the knowledge to tackle your next framing project. Let's start with the basic components of a wall frame. Understanding these components is crucial for anyone interested in construction or home improvement. Each part plays a vital role in ensuring the stability and integrity of the structure. The plates are the horizontal members. They form the top and bottom edges of the wall frame, providing a base and a cap for the vertical studs. They are usually made of lumber. Lumber is chosen for its strength, durability, and ease of use. It's essential to select high-quality lumber to ensure the longevity of the structure. The bottom plate sits on the floor. It is the first piece of the wall frame to be installed and is anchored to the floor to provide a stable base for the rest of the frame. The top plate goes on top of the studs. It caps the wall frame and ties all the vertical members together, ensuring they remain upright and aligned. Sometimes we use two top plates stacked together. This method is often employed to add extra strength and stability to the wall frame, especially in load-bearing walls. This is called a double top plate. The double top plate helps distribute the load more evenly across the wall frame, reducing the risk of structural failure. Studs are the vertical members of the wall frame. They are spaced evenly along the length of the wall and provide the main support for the wall structure. Think of them as the ribs of the wall. Just like ribs in a human body, studs give the wall its shape and strength, supporting the weight of the structure above. There are a few different types of studs. Each type serves a specific purpose and is used in different parts of the wall frame. King studs are full-height studs that run from the bottom plate to the top plate. They are typically placed on either side of openings like doors and windows. Jack studs are shorter studs that support headers above doors and windows. They transfer the load from the header to the bottom plate, ensuring the opening remains structurally sound. Common studs fill the space between king and jack studs. They provide additional support and help distribute the load evenly across the wall frame. Finally, we have headers and sills. These components are crucial for framing openings like doors and windows. Headers are like beams that span the openings for doors and windows. They carry the load from above and transfer it to the jack studs on either side of the opening. They transfer the weight of the structure above the opening to the jack studs. This ensures that the load is properly supported and the opening remains stable. Sills are horizontal members that sit below window openings, providing support for the window unit. They help distribute the weight of the window and ensure it is properly aligned within the frame. Before you start nailing studs together, you need to plan their placement or layout. This initial step is crucial because it sets the foundation for the entire structure. A well-thought-out layout ensures that everything fits together seamlessly and that the building will be both strong and efficient. Studs are typically spaced 16 inches apart, measured from the center of one stud to the center of the next, called on center. This standard spacing is used because it provides a good balance of strength and efficiency, making it ideal for most residential construction projects. This spacing provides a good balance of strength and efficiency. It allows for the even distribution of weight and ensures that the wall can support the load it is designed to carry. Additionally, it makes it easier to install insulation, drywall, and other materials. However, depending on the load-bearing requirements and local building codes, you might use different spacing, such as 12 inches or 24 inches on center. For example, walls that need to support heavier loads, like those in multi-story buildings, might require closer stud spacing to ensure adequate strength. Maintaining a consistent layout is crucial, even if it means making minor adjustments to align with other elements like doors or windows. Proper alignment ensures that these openings are structurally sound and that the overall integrity of the wall is maintained. This ensures the wall is structurally sound and can support the weight of the roof and other components. Regular inspections during the framing process can help catch any issues early, ensuring that the final structure is safe and up to code. Proper planning and execution of the layout are essential steps in any successful construction project. Creating openings for doors and windows requires careful planning and framing. These openings are called rough openings. They are slightly larger than the actual door or window unit to allow for adjustments during installation. A door opening consists of a header resting on two jack studs, king studs on either side of the jack studs, and a rough sill below. Window openings are similar, with a header, jack studs, and a sill. The width of the rough opening should be the width of the window, plus the manufacturer's recommended clearance. The height is calculated similarly, adding the height of the window unit sill and any necessary shimming space. Section 5. Navigating wall intersections. Wall intersections, where two walls meet, can seem complex at first glance. The key is to maintain the same layout you've been using throughout your framing. Don't let the seemingly doubled-up studs at the corners confuse you. For a strong connection, make sure the studs from one wall intersect with the studs of the other wall. Use nails or screws to secure the studs together. Always check your work with a level to ensure the walls are plumb and the intersection is square. Section 6. Choosing the right lumber. Using the correct lumber for your framing is essential for a strong and long-lasting structure. The choice of lumber can significantly impact the durability and safety of your build. It's not just about picking any piece of wood, it's about selecting the right type that suits your specific needs and conditions. The type of wood, its dimensions, and its moisture content all play a role in its strength and stability. Different types of wood have varying characteristics. For instance, hardwoods are generally denser and stronger than softwoods, but they can be more challenging to work with. Softwoods, on the other hand, are easier to cut and shape, making them a popular choice for many construction projects. For most residential wall framing, you'll use either spruce pine fir or SPF or Douglas fir lumber. SPF is a versatile and economical choice, commonly used in North America. It combines the properties of spruce, pine, and fir, offering a good balance of strength and workability. SPF is readily available and more affordable, making it a go-to option for many builders. Its cost-effectiveness doesn't compromise its quality, making it suitable for a wide range of applications, from framing to general construction. While Douglas fir is known for its strength, Douglas fir is particularly valued for its high strength-to-weight ratio, making it ideal for structural applications where stability and durability are paramount. Its fine grain and minimal knots also contribute to its superior performance. The dimensions of the lumber refer to its nominal size, which is slightly larger than its actual size after drying and planing. Understanding these dimensions is crucial for accurate measurements and fitting during construction. For example, a 2x4 stud actually measures 1.5 inches by 3.5 inches. This discrepancy is due to the drying and planing process, which reduces the wood's size from its original cut dimensions. Knowing this helps in planning and ensures that your construction is precise and fits together perfectly. Section 7. Fastening your frame together. Once you have your layout and lumber ready, it's time to start assembling your wall frame. While there are various methods for fastening framing members, nails and screws are the most common. Nails are a quick and cost-effective option. They come in different lengths and gauges or thickness to suit different applications. Screws offer more holding power and are less likely to work loose over time, but they can be more expensive and time-consuming to install. Always use the appropriate fasteners for your project and ensure they are long enough to penetrate through both pieces of lumber and provide a secure hold. Section 8. Common framing mistakes and how to avoid them. Even experienced framers make mistakes from time to time. Being aware of common pitfalls can help you prevent costly errors and ensure your framing is done right the first time. One common mistake is not using a level frequently enough. It's crucial to check for plumb or vertical alignment and level or horizontal alignment throughout the framing process. Another frequent error is not accounting for the thickness of sheathing and drywall when framing rough openings. This can result in openings that are too small for the doors and windows. Section 9. Level up your skills, resources for further learning. Congratulations on taking the first step towards mastering wall construction. Remember that practice makes perfect, and the more you frame, the more confident and skilled you'll become. Don't be afraid to seek out additional resources to further your knowledge. There are countless books, websites, and videos available that delve deeper into specific aspects of framing, such as advanced techniques, building codes, and working with different materials. Local community colleges and trade schools often offer hands-on carpentry courses that can provide valuable experience and mentorship.